Can you see my screen all right? Okay, great. Let's read over the questions. Chaining languages and changing units of measurements, Fahrenheit and Celsius. Okay, so it depends on the API, but with the Open Weather API, they actually have a separate call for both units and as well for Kelvin. So I guess I'm going to have to ask to clarify it later. Make it clear. Okay, this is a very good point. The main purpose of this task was to show you that it's actually quite difficult to create big software, and the weather app is quite a big software without having a framework or without having any sort of structure. And it was kind of requiring you to figure out your own structure and so reinvent the wheel. And later, when you start learning Angular and React and other frameworks, you will see how everything becomes much easier once you have a framework to have. Okay, so about the bilingual. Okay, so is it okay to fetch data for English and Polish version at the start of an app? I think you are supposed to be fetching every time you change the language, because as soon as you change the language, you'll have to get new. You'll have to retranslate the city name, the date name, and the weather forecast. And I'll show you in my code how I implemented this as well. Okay, so we have quite a lot of questions about the languages. So let's maybe show you that. So first of all, let me, so you probably have seen this nice app as an example of what you were supposed to build. The requirement said that you can implement any interface you want, but it is important that you have functionality of changing the background image, as well as having a certain set of languages to translate, and some other features. Well, you probably know all of them, so I'm not going to take too much time covering that. This weather app is an example of an event-driven application. So what I mean by that is whenever whatever the user does on in the interface of the weather app, something has to happen. In this case, for example, let's just go over examples. We have this icon change image. When we click on that, what has to happen? Well, we can send a request to the images application and get an image and place it in our background. That can be that. When we change the language, it's actually becoming a lot more complex, because we have to translate static text as well as dynamic text, which can be seen on the here, because this text is actually a response that comes from the weather API. So when we change the language, we have to make the request to a weather API. We have to then make a request to the image API to update the image so that it corresponds to the weather. And we have to make a request to the map API so that we have a new map. Okay. Sorry, okay, nothing special here. Let's take a look at the input field. It's kind of the same event that will happen when we type a text and start searching, then we just simply update our view with corresponding data. Here is my little implementation of the same API. As you can see, I'm not very, I wasn't very extremely keen on. Now, I guess my network is quite slow so when I'm recording and communicating with you, but it's similar interface, similar everything. Let's try just Gdansk. So here, yeah, everything is very slow, but quite similar events and quite similar logic. Okay, now let's move to coding. I'm going to show you how I've coded this project from scratch. I have tried to follow as many requirements stated in this document for your technical specification. It's very important to follow all of the functional requirements which are stated in the 3 units. But then all of the other user stories and technical requirements are obviously also important to implement. Now, there were some advanced features, a lot of APIs like, where was I? Like there is the speech synthesis and API, or the navigator geolocation API. That are in the browser in Chrome. So they were nice features that you could have implemented if you had the time, but you probably haven't, since it's quite a big task. I have a message, please share screen. Can you see my screen? Okay, yeah, sorry about this. Now here we go into my project. So since the task requirement stated that we were supposed to use Webpack for our module bundling, here you can see my Webpack configuration. It's quite a simple file. I have added everything that was also, let me maybe make it bigger for you. Yeah. So let's take a quick look at that. Webpack config file helps Webpack know what let's see, for example, the entry file. So here we state, well, our entry file is the source index. And if we take a look at my project, we can see this index file right here, and it's going to be the first file that Webpack is going to take a look at, and it's going to bundle everything starting from this file. So it's my first file. And here all I do is I create an instance of my weather app, and I pass it a node from that I have in HTML. So here is my simple HTML. It's just nothing special, because this whole app is supposed to be client-side rendered. So we shouldn't have any HTML tags in here, except for maybe some node for mounting our application. I would also like to mention that it is important to make our HTML file valid. What I mean by that is it has to have a doc type, it has to have HTML tags, and just standard tags, standard head tags. It shouldn't be just an empty file at all, because otherwise the browser is going to take the responsibility of auto-correcting our malformed HTML file, and that's not a good thing. Okay, let's go back to our Webpack config, which bundles our whole application so that it can be displayed and run, right? So we took a look at the entry file. Now the output file is going to, the output directive is going to tell Webpack where we would like to store our bundled files. So in my case, it is just a simple dist directory, and the file name, you can name it anything. Well, you can't see it here because I haven't actually built a production version of the file. Modules are quite interesting, and I have quite a lot of them just because I needed them. But the important part here is that for JavaScript, if we use any modern syntax like async await, we need a Babel loader so that it transpiles our modern code into something that older browsers can understand, and so that they don't crash. I needed to include a CSS loader because I am dynamically importing CSS files in JavaScript via ECMAScript imports. Interesting thing about loaders, you can change them, but the order is important. So in this case, the CSS loader is going to be run first, and the output of CSS loader is going to be then piped into the style loader. And it's important that we keep our order correct. Next, because I have some images, I'm also including file loader. And for fonts, I'm also including a file loader. I have used this special fonts for displaying weather icons. And then we have the SVG loader. And so that I can run my application, which you can see it's running right now in dev mode, and I have hot module reloading and all of these nice features. I have also installed the Webpack dev server, and this is what is running currently in my browser. Okay, so let's just take a look at how to set loading SVG in Webpack. Okay. Yeah, so I have used, there are two ways. So we can, if you think about SVGs, they can be loaded as SVG elements, meaning HTML elements, and as images. So here I'm using an SVG inline loader to load SVG as an XML file. And I could have also included SVG extension here in my file loader, but then it would have loaded it as an image. So there is a difference there. If you think about images like PNG and JPEG, they are loaded into the image tag. And an SVG inline loader loads our SVG inline. So let's just see where I did I think it's this little icon that I used for SVG. Like here, SVG loader in Webpack loaded the file not as an image, but as a real SVG tag. Okay, I hope that answers your question. And let's keep going further into our little app. Okay, so another question. Thanks, Hero. You're welcome. So the simple Babel RC file just tells Babel how we would like to transpile code from the modern syntax to an older syntax, but this is the simple preset that is commonly seen everywhere. I guess the last thing about Webpack I'm going to say is that usually when you use a framework like React or Angular, any sort of build tool that you use is going to have some sort of module loader under the hood, and you don't really need to know it that much unless you are going to be creating libraries yourself or frameworks yourself. Usually it's just all of this functionality is hidden away from you, and you don't even have to care about it. But it's just nice to know some basic configuration just in case you have to do this kind of task yourself, right? Okay, I don't really know if maybe you know, but let me just talk about it anyway. So here I have my package.json file, and in the scripts section, of my file, we see all of the commands that we can run. And the way that we run commands is by saying npm run and then the name of the script that we would like to run. So if we run build, we're actually going to build a production version of our weather app application that we can then host in any, and you can see the dist folder. And so this folder is the folder that can be hosted in any static site hosting platform like Netlify, GitHub pages, or just you name it. There are a lot of tools that, there are a lot of services that can host your apps. But the command that we are really interested in more often is just npm run start, because it starts development server. The names on the left-hand side are arbitrary. They're just very common names to name scripts to run. So that's how I named them. All right. So we have covered our basic configuration and setup of the project. Now let's move on to the actual code structure. All right. So I have tried to implement something along the side of MVP design pattern, even though it's not really the same exact design pattern as people consider MVP when they're talking about backend development, where they have the controller, which is the entrance point after, so to say, the entrance point to the application, and then we have the controller makes a request or some calls to the model, gets all of the necessary data, and then places that data in the view, which has some templating engine running there in the view, and then gets that rendered view and it sends it away to the client. In our case, because our application is interactive, we can't really have this static MVP. So I still have named it that, but it's just for because I guess I couldn't have come up with any other names. But you shouldn't consider what I'm doing here as an MVP ideal MVP design pattern. Okay, so when we looked at in the index file, oh no, that's the wrong file. So here we have the instantialization of our weather app, and now I keep getting to this file. And in the controller, we actually have this class. What it simply does, it takes our node where we would like to render our app. It sets up the model, and model is something that stores all of our data. And all of our data, what I mean by that, it stores what an object that has, well, I'm just going to show you it later, okay? It's then sets up the first action in the model, which tells it to go fetch data from the weather API, because that is what has to happen no matter if the user does something or not. When our app loads, we would like to show the current data for the user's location, the current weather. So that's what this action actually does. And then we have the view, and the view is what it has all of the logic of interacting with the DOM. So that's the reason why I passed the DOM node, and I have also passed the model to the view, so that the model can the model is going to basically emit events, and the view is going to subscribe to them, and that way update itself when it wants to. And so the way I have implemented the model is something known as the observer pattern. It's a very common pattern in event-driven development. That's actually what DOM is built on. Every time we do add event listener or remove event listener or dispatch event on the node, we are actually using the observer pattern, even though maybe we don't even know that. Okay, so let's now then talk a bit about model, because it's the piece that is most interesting in this task, because it's mainly focused on making you know how to use the um, APIs, how to do async coding, how to make network requests, how to interact with external API services like the weather service or the IP service or the map service or what name you. And the view is what is typically done by the framework. And in this case, we had to code it by ourselves. And I have to say, this is the most not interesting thing to do when you know how to do something using a framework. It becomes very low-level coding that is prone to errors and is just not very exciting, to be honest. Okay, but now let's talk a bit about model. Like I said, here we have our instance of the model. It's quite a heavy class. I could have refactored it into simpler subclasses, but I wanted to demonstrate you the idea of having a global store of all of the data so that the view can always get the data that it wants when it the data that it needs to render its state. Okay, here I have my weather model. And in the constructor stage, whenever we are instantiating it, we are saying, so here I have extracted all of the data that our app needs, which is the language, the temperature, the geolocation, which is simply the city or country. And I have just also made a comment saying that, okay, I want it to be fetched from IP info. It can also be fetched from this Navigator geolocation service. Okay, what did I just do? I have moved there. Okay, but again, doesn't matter that much in this case. So the current weather is going to store the object from the weather API, and coordinates can be a separate object, or they can be just also in the current object. We have background image, and I have a list because my API returns a lot of them, and I wanted to cache some of the images so that I don't have to make too many requests to my image service. Okay, and this is the store that I have. Initially, some of the data is not there because the network request is only going to be made at the point, well, we saw the init method, which is going to talk to our geolocation service first. Also, just wanted to mention just briefly that I have implemented my asynchronous programming via promises, just because it's a little bit more difficult than doing async await once you know how to do async await. So that, yeah, this is done in promises. We can see that, well, I have created a set of services that so that I can divide my logic into so to say corresponding locations. For instance, geolocation service is purely responsible for fetching data from the geolocation service and displaying us that data, or just giving us the object. So also I have the image service that fetches images from the image service. The storage service is dealing with the local storage, so that because we have this requirement that until the user selects a different language or a different unit for measuring well, you know, Celsius or Fahrenheit, we're supposed to display everything in Celsius and in English. So storage service stores our configuration for that. And we have a translation service. I'm going to talk a little bit about it because I saw a question about how should we do translations in our app. And then we have the weather service, which deals with the weather API. Okay. So initially, when the program loads, we are making requests to the geolocation service. And when we get a response, we are making a request to the weather service. And that is how we do our initial render. Okay, let's take a look at the weather service. Fetch weather, it's quite a big service, quite a big method, but here I'm making two requests, one to the weather service to get the current weather, and the second one to get forecast weather. Just because our service can't, I found it that it does not return forecast data in one request, so we have to do two. And we are using promise.all method so that we are sending our request in parallel, but then we have we are dealing with it in series, because then, yeah, here is our handler for the current weather. Just see. Can you share a link to your wrapper so I can have a look at it? Yeah, sure. I'm going to share it later. I would also like to say that I've spent not that much time working on it, so I maybe should improve it a bit more before I share it. But okay, let's see. Like I said about the store. So this model, it stores all of our data, and but how does a view which represents our DOM nodes, how does it know when, for example, when we finally have forecast coming in or our weather coming in? The way that it's going to know is because we have implemented the observer pattern. So our weather model, it extends its base model, which if you take a look at it, is exactly what an observer pattern does. So here we have a way for anybody who would like to subscribe to our model to add a listener. And so they specify which type of listener they want. And that way, all of the listeners are stored in our model. And whenever we have an event that we'd like to tell everybody about, and an event can be, hey, I have some new weather, or hey, the language changed, or coordinates changed. It can be any sort of events. We notify all of our listeners so that they can do whatever they want with this information. And our listeners, what they're going to see to do if, for instance, whether the forecast changed, they're going to re-render their themselves. Okay, so now I guess we can take a look at. Let's take a look at the view part of our app. So I have created. This is the base. Let me also briefly show you the events. So the events that I have created are the following four. So we have an event when the background changes, the current weather changes, the coordinates, and the language. Now let's go back to the view. So this is also the first thing that gets rendered inside of when we start our app. Here is all of the nodes that get attached to the DOM right away. We also don't display anything until we have, so we can see here it's the display none, so nothing will be shown until sometime later. And that sometime later is going to come, let's see when. Whenever here we listen to event current weather, and when that event fires, we know that there is current weather. Now we have the weather, and so we start showing our app. Okay, now I needed to add all of this HTML tags so that they are mounting points for our other views. I didn't want to put all of the HTML just in one single JavaScript file because it's a lot of logic that just sometimes shouldn't be in one place. But then I have a lot of other views. For instance, we have map view, or, you know, so pretty much for each functional component, I have created its own view. And that view receives a node where it should be mounted. So for instance, we have here a map, and it corresponds to this tag. And so that's where we are going to, for instance, load our map view. And then we pass in the model to our view so that it also can interact with the same store, with the same weather model. Okay, let's see some more questions. Okay, no more questions thus far. All right. So also I have missed a semicolon here. So let's take a look at our map view. So our views are all very similar in structure, and well, the map view is a little bit more heavy just because it also has this external service for showing a map on the page. So I don't. Let's see what this service does. So I'm attaching node here. What attach node method does is it adds the template that we would like to add to the page to the DOM node that we have specified when we constructed our class. Now, this is just my idea of making manipulating the DOM in a little bit of an easier way, because I didn't want to create every element by hand by, you know, just doing document.create element and all of that, because it gets very tiresome once you have a lot of elements and it's easy to mess it up. So it's just easier to insert it for me as a simple, you know, inner HTML equal to something. Okay, but here it's interesting the way I had to do this, for instance, with the script, is that I couldn't have just added the script tag inside of the template, because then I couldn't listen to an load event to start displaying my map and update my map. So I don't know if you had similar issues or not, but also I haven't used the Google Maps services, so maybe their maps can be added to the to DOM somehow easier. But again, don't really know. So you can see that the views are quite messy, just because they deal with all of the DOM, and DOM is a low-level API. It does not have that, in my opinion, the APIs, a lot of them are quite cumbersome. And so the code is also quite cumbersome. That's why we want to separate all of the view logic away from our model or our business logic. So here you can see my base view. The base view is just a way to define all of the, for me, it was a way to define all of the allowed methods on the view that are guaranteed to run. So here, for instance, I have, you know, a view always has a place to mount. So this is the mounting node. It also stores the model. Then it has a reference to a translation service. And we are going to talk about translation service a bit later. But this is kind of how all of our views have a way to translate themselves once they need to. So that's the instance of that. And then there are three methods, which just can be any number of methods. You can see that they are empty. So in an ideal world, they would be abstract methods, but because JavaScript does not have that abstract keyword, we just kind of have stubs for them. And these are, so to say, lifecycle methods, or in React, they will be called hooks, but they are just my custom methods. So what the setup method is supposed to have any logic before node gets attached to the DOM, then the attach node attaches the node to the DOM, and after attach just does something after DOM node has been attached. So it's just one of the ways to separate this messy JavaScript DOM API code in different methods. Okay, let's just take a look at some of the simpler views, just so that you can see a little bit of more interactions of it and the model. Maybe let's go to the language selector view. It's not that big, so it should be hopefully easier to understand. So our language selector view is exactly the view for this little component, language selector. As we can see, whenever we click on the language, everything gets re-rendered to the correct language. Okay, the way it is done is, so we have this attach node method that you already saw on the base view. It has, so it extracts the instance of the translation service, and my translation service has all of the supported languages in it. And in my case, it's just the English and Russian, because that's all of the languages I know. And okay, and so here we have our template, and we are dynamically adding our languages to the selector. So this is just so that whenever we add another language, we can quite easily just simply add a separate language, and it just works. Okay, then we attach our select component to the DOM, and we say that our selector, it's an interactive element. It can change because the node can trigger change event. That happens whenever we click on the options inside of the select. And in that case, we would like our model to set a language of the target's value, which in my case would be either English or Russian, but it can be any other language as well. But our view also listens to events of the language change. It doesn't really have to, because it always knows the correct language, because it's the component responsible for it, but I just wanted to separate the logic. And in our case, it's going to have a title. It's going to change its title, which is this text, to be the title from the correct language. This is just for accessibility reasons, because we'd always like to have as much accessibility information as possible. So here I will have changed language. If I change it to Russian, our title changes. Okay, and this is the way this language changing is done. Let's just quickly maybe try to actually add another language to our app. Let me maybe try to have them side by side so that it's a little bit easier for everybody to see. Now we come to the translation service of our application. So translation service is not a big file. What it has, it imports all of the translations, which we're going to see later. And it is a static class that exports several things. So it exports the list of supported languages as an object, so that we can say translation service. So that way we have nice auto-completing. So we could, for instance, say translation service.supported languages dot, and we have a reference to all of our languages. And also, we have this, so if you think about this little object, what it has this text. Well, it's an object that reference, it's a, so it's a computed property that would in the first case be in en, in the second arrow, and it maps that value to the imported value from our dictionaries. Okay, so now let's try to add another language. Before we do that, let's see the translations that we have. So we have English, which is just a very simple file. It's just one default export with some of the properties that I have translated. You can easily see how we can add other properties to this object. But also, let's see the other one for Russian language. So that would be the Russian language. And now let's create another one, just for funsies. And which language do we want to create? I don't really know any other language. So let's just create a customary, not customary, just cat language. Let's do cat language. So we'll just do the same. And here we would need to have our language translated. At this point, it can be done by a translation agency or anybody, and we'll just say meow. Let's just have a lot of meows here. Fahrenheit. I don't think I had those translated. Search city meow. And let's have latitude, which is going to be long, and longitude, which is going to be, no, wait, it's the opposite. Longitude is the long and latitude is the wide, or it doesn't really matter. Okay, so here we have created our cat. And in order to add it, we would say translation service, and we would import our new from our file. And we'll still not see anything, unfortunately, right? Because we need to add our language to the supported languages list. And so let's say cat. And finally, we need to add, the linkage of our language. Now we have everything reloading. And so hopefully now we'll see our new cat language, the ability for us to have a cat language. We see our cat language in the list, and now we can see our translations working. So this is just for us to, it's going to be quite easy to extend any translation now, but for any developer, right? Once you explain to them what the approximate process of having a translation, okay? So that is the translation service. Now let's move on to storage service. Well, storage service is quite simple if you know how local storage works. In JavaScript, it's just local storage is a way to have a persistent storage of, persistent storage of data across sessions, across browser being closed and open, and across even the computer being turned off and turned on. So it's the primary way, along with maybe cookies or IndexedDB to store data on the front end. In our case, whenever we have this storage service class, and when we instantiate this class, we check for if there is data in local storage, and if there is, for instance, a language key in our local storage, that's the language that we are going to start from. And if not, we are going to be using default language, because the default language is what we have the default language stated in the specification, which in our case, the specification is the tasks, the task description. And that's the language and the temperature unit we will use. So for instance, here, if we change the language to RU and the temperature to Fahrenheit, we are supposed to have this information being stored in local storage. And anytime that we now reload the browser, we see that we start off from the data in our local storage. That is just simply done by having the service, by having the data being retrieved in constructor, right, before we instantiate our views, or just as early as possible. So that was done in our model, weather model. So we see this is where we have on constructor of the model, we have extracted the language and the temperature unit from local storage service. Storage service. Okay. And whenever a user clicks on the selector in the language selector or the degree, how would they say, the unit selector, we update our local storage by simply, whenever we set a value on the local storage that is language or a temperature unit, they are set to be getters and setters. So whenever we set the value on our storage service, we update local storage at this point, so that we always keep track of store our language and our temperature units so that they are correct values. All right, so now we have actually already talked about the majority of important services. So we have talked about storage, about translation service. Now we have the other three, which are all network services. So they are all require, this making a network request and having to deal with an external API. And what I mean by external API is, sorry, I'm just, all of these external APIs that have been also listed for you to use in the task. Okay, let's go back to my, let's just take a look at one of them, because they're all pretty much the same by the way they work. Now, here is a weather service API, which I have used just the first link, which was the open weather map. This service. It could have been any one listed in the task description. I have only looked on the first at the first link, and it's quite a nice service, anyways. Let's see how this service is done. At this point, it's actually not very good, because I'm storing my API key, which is right in the weather service. Usually in production level application, an API key is going to be stored not in your applications at all. It's very bad practice, because the API key, it's sensitive information. Sometimes it's really only your own API key, so another developer can have their own or whatnot. So usually there is this .env file or any sort of secret file that is not committed to GitHub repository and stays on developer's machine and can be, and so every developer has their own file. I have created this file, but I have still not imported API keys from this file, just because I didn't have time, and it's just become, sorry, just clicking everywhere. It's a little bit more complex because then we have to update our Webpack and have a way of, so Webpack has the special plugin that you can use so that all of the these keys, they can be injected into your application at by Webpack, and you would have access to them via, so let's go back to the weather service. There is this, there is, okay, I just don't remember, but it's something along the line of object.env, and then your key. Now I have moved on to the weather model, but I was talking about the weather service before. So like I said, an API, this is not a good practice, but just for demonstration purposes, it's just okay for me right now. And my weather service has two methods, just because like I said, we have separate calls for getting the current weather, which shows the weather for, let me switch to English for you. It shows the current weather, and the forecast, it gets shown via a separate call, just because of how the API works. So this object gets, this method gets all of the required properties it needs, like city and country and language and unit, because it needs them to make a request. It then combines them into one single URL, which in my case, I have used this, I've written this compose URL method that is just create and combines the URL from the endpoint, which is our API endpoint. Then we have the path, which is weather or forecast with the correct data, and then all of the params. So these methods are actually extremely similar, and it's a good point to refactor them so that there is not a lot of code duplication. Because right now you can see that they're almost identical, like, except for, now this is not good. This is not good. It's definitely something that I would have, I need to refactor. Okay. So that is what a service that's what a service pretty much is. And geolocation and image service, they are similar. They just make a fetch. So I've used the native browser fetch request that fetches the request, and then just because I always know that I'm going to receive JSON, it calls this .json method on the response. Here you can see that I'm not doing any error handling. So what if the response did not succeed? So this method leaves that to be the responsibility of the callee, so of the whoever calls the current weather method to deal with error handling. Now we have covered services, we have covered the model, we have covered our translations. Utils. So the utils folder contains all sorts of methods that that should be extracted away for reuse. So in my case, I have this format time method, which it is actually the method that converts time to the correct time zone. As it turns out, it's quite a, not, I wouldn't say tricky, but it's quite a method. So if you had challenges converting the date to the time zone of the user, then we can discuss it. So the problem here is that the browser has, you have your own, so whenever I do my new date, I have my date in my time zone. And when I'm querying the API, it does not give you any time. It gives you an offset, and then it's your responsibility to figure out how to convert it to the correct time. And it's quite quite a conversion, but the task requirement stated that you need to use the local string. Where is this method? The local string method to do the conversion. And if you have just read the documentation, then you would have, I guess, written something along the lines that I have here. And I also wanted to talk a bit about, hopefully you noted how much reading a developer has to do. So it's not just enough to know all of the syntax of JavaScript and say of TypeScript, and then all of your methods and logic of your framework. You also get tasks to integrate with some sort of service like a weather app or an IP service or an image app, and then you have to somehow know what to do, and you have to read a lot of documentation, and so that you write correct so that you interface with the external service correctly. And it's like something that never ends. At least in my mind, I never feel like, okay, now I'm safe. I know that, like, I know everything I need to know about the front end and the JavaScript. No, it's always something to learn. And hopefully this task shows you that a developer has to do a lot of technical documentation reading, because that's sometimes the only information you have. Maybe sometimes Stack Overflow, but not even all of the time, right? Okay, let's see. We haven't taken a look at. Okay, let's see. Something about the MVP scheme on your own for this application. See, I haven't really. The way I understand MVC is not. My implementation does not exactly correspond to that design pattern, just because MVC is often considered to be a back-end pattern, and whenever you start using it on the front end, it's becoming a bit controversial, just because there is a very clear set of directions in which MVP pattern goes. So we have the model. It communicates to the controller. It communicates to the model, gets the data back, goes to the view, gets the data back from the view, and then sends it back to the browser, for instance. In our case, we really have a situation where we have a controller that just sets up connection between the view and the model. And then after that, the controller doesn't even do anything in my case. As you have seen, my controller is very tiny. So I have thought about, should I just rename it so that it doesn't become confusing, but I just couldn't also come up with a name, so it just stayed a controller. But it's not, as far as I know, Angular is an example of an MVC pattern. I haven't worked with Angular, I have worked with React, but maybe you should just look into the Angular world to see how an MVC is done in the front end. And also, my application is not really a framework. It's just an implementation of a small task. So it's not generic at all. Okay. In production, it's stored in environment variables, or is it better to store API keys in submitted to GitHub file? So yes, as far as in production, all of the environment variables are stored in env files, and they are not stored in your repository of your project. So you shouldn't mix your code with your API keys, because for a lot of reasons, it's actually considered one of the security breaches. So in security trainings, we always get told about, hey, just don't put any of the API keys in your code. And a lot of vulnerabilities, as far as I have heard, have been found by somebody parsing through, not parsing, crawling through, scraping repositories and finding a lot of sensitive keys in them. Okay, somebody's having an interview. Good luck. If we had a class York, could searching for York break our application? Okay, I don't understand this question. If you can please clarify this. Also, yeah, it's an interesting point about searching for cities because, for instance, there is a lot of cities have the same name but are located in different countries. That often happens for the USA. They have a lot of names similar to other from the world. For instance, St. Petersburg in Russia. If I'll try to look for it, I'll get the result from the US, which is wrong in this case. So the way I have solved it for now is I specify the city and comma and then the country. Which, okay, now St. Petersburg. Okay, now it found the Russian city. I guess we have covered pretty much all of the structure of my weather app. Now let's maybe move to the difficult, so to say, difficult things that I have considered challenging for myself when I was doing this task. Probably you also had the same challenges. Let's just take a quick look at questions. They have Warsaw and Krakow in US as well. Yeah, so this is they have a lot of cities from all over the world. Apparently, whenever immigrants come, they just name a city in US, used to name with their home city name. And so this is also why you would want to read the documentation for your API, because, for instance, for open weather, they clearly state that if you use a city without a country, they are going to search the USA. Sorry for a second. I need to take a drink. Okay, now let's keep moving with questions. Okay, how background image can be loaded smoothly? Now, that's a good point, Natasha. I haven't really thought about it when I was implementing it, and I guess you've noticed that it's rough. Let's take a look. Okay, let's think about something here. So we have let's actually take a look at how I'm loading images then for the background. So whenever we make a request to the weather service, then we have after we get the successful response, we start looking for an image, and we have the weather app view responsible for updating, and because it has subscribed to the background change event. So whenever we have that event triggering, we have a URL. And what I'm doing is I'm just setting up the URL and then querying Selector and setting its style background image property. So this is the CSS way of loading, of doing the background image. So if we take a look at, okay, not a lot of space. Yes, come on. So if you take a look at this container, this is the container that stores the image, and we are just simply specifying the URL for loading the image. Now, I have very bad connection, but you've made a very valid point that it's very jarred. Now, the CSS does not have a way of caching an image or just doing a better way of loading it. So what we could maybe have done is we could have loaded the image and then hoped that it's going to be loaded from cache, which is not even a guarantee. So let's maybe try this quickly. So we have the background image, this format background image, but we have the URL. Okay, let's just create an image then. As an example. And then we do image dot onload. Let's first off see that we are working correctly. So load image. Okay. And then we'll do this method. Now I don't really know if we'll be successful here, but let's see. So probably not, because I still keep seeing we have the event fired or not. Now let's try again. I didn't see. We have compiled successfully. Okay, let's rerun this app. I have some debugging information in my console. Now the app is really loading very slow. Yes, see, we don't have an event happening ever because we don't see anything in the console. Maybe that is because we actually have to add the element to the DOM. Like, I don't really remember. Let's try to add it to the DOM. Document dot body dot and nope, doesn't want to work. Really, really looks like it should. Maybe I'm just missing something, but so what I was trying to do here is just create an element, add it to the DOM, and once they oh wait, that's stupid of me. I didn't add the source, of course. Image.source. Well, how was that supposed to work? Is equal to the URL. Oh, still nothing. Now it really looks prominent. Console is not a function. Console.log. Yes. Well, looks like it's much smoother. Let's try again. Now my map is gone, but that used to happen. It needs some more time. Now this feature works because I'm caching my images. Oh no, it's the image. I'm caching the URLs. I'm not caching the images. Okay, let's see again. Now we have the default background, and after some while, we have the load image event and we have the data. So this is one of the ways of having this application not have the background being, being loaded unevenly, but this is just taking advantage of the fact that the application caches its images and its resources, because so first we're loading it as a separate image, and then we are appending it to the, which you can actually see here. So what we'd want to do is just hide this image so that it doesn't, do this. But then in the end, hopefully the image loads better. Okay. jQuery, I think from the past, that's probably a good point. As far as I've been working in, nobody has used jQuery for the past 4 years, for sure, in my life. But some people still use it. It's kind of there, but I definitely wouldn't invest in learning it too much, as a lot of recent browser API methods like query selector and and others, they used to not be there, and that's when jQuery was very useful. Just for a lot of the usage I got out of jQuery back in the day was to select elements, because JavaScript only had not JavaScript, but the DOM API only had like get the element by ID, by tag name, and a class name. You couldn't select really more advanced. We couldn't use advanced selectors, and now that the DOM API has these selectors, really jQuery is, in my opinion, not very useful. Okay, so no more questions. Now let's discuss difficult features. So in my opinion, quite a difficult feature, not so to say difficult, but just a little bit more challenging, was to create to have time be of correct time zone. Because if we take a look at, for instance, my current time right now, let's just do an example. So where I am, it's currently 21 p.m. And as you can see, for instance, let's do Gdansk. And according to my app, it's currently 8 p.m. in Gdansk. And how would you do that, given that you know your current time zone of your browser, and you only know the time offset that comes from the API, from the current from the API? For instance, in my case, the API returns an object that has the time zone property, and it has this number. So you have to somehow figure out how to use this number to convert time to the correct time zone, so that it displays in that city's time zone. Let's try to, I guess, demonstrate that on an example of Gdansk. So here we have Gdansk, and it has an offset of 7200. Very interesting. So the way this API, and an API can return an offset in very different shapes or forms. For instance, in JavaScript, we have the date to time. Wait, what's it? Date? Yes. The get time zone. offset, and it returns quite a different offset. So in JavaScript API returns an offset from the GMT time, which is this London time, as you know. In my case, I am to the right of London. So in terms of like I'm in the eastern side, and my offset is negative for that reason because my time is greater than in GMT. And this is the offset in minutes from GMT time. So, okay, minus 180 minutes. If we multiply this number by, oh, let's actually divide this by 60, and that gives us hours. So, okay, I am 3 hours ahead of GMT. What the time zone in the API that I used returns is, as it turns out, it returns the offset, but it's going to be positive, even though it's also to the right of the GMT. And it returns the number of seconds, not hours. So in that case, we would divide by 60 to get minutes, not minutes like before. So that's 120 minutes, and then by 60 to get hours. So you can see that in the JavaScript native API would give you in that case minus 120, and this external service gives you 720. So totally different. But now let's try to convert my time zone to Gdansk time zone. So, okay, let me maybe make the browser console bigger. And we remember that time zone offset in Gdansk is 720. So that's the offset. And I also always have to remember that now it is in seconds. So first, to convert time zone of Moscow to time zone in Gdansk, I'm going to first make a transition of time zone of Moscow to UTC time. So let's say UTC time is going to be my current date. Oh no, that's just the current date. And then let's just start with my current date. So my date is this, and then the date dot to, okay, get time zone offset. So this is the time in minutes. So then we multiply that by seconds, and then we multiply that to milliseconds. Oh, and that's the milliseconds difference to the GMT time. So the GMT then is going to be my current date. The time gets the current timestamp in UTC timestamp format, just going to be a number, and we are going to add that to our offset. So that's supposed to give us the GMT time, current GMT time. So which happens to be this 1823. So hopefully that's the time of GMT. But that's still not close to our Gdansk time, because Gdansk is 80 something, right? Okay, so to convert to Gdansk, we should then use the information about our offset. And so what we would do is we'd say GMT, so Gdansk. Time is going to be, again, we create a new date with the GMT time. We get again timestamp. Then we have to add our offsets to it, because so this way we can convert it to the time zone, but also we have to understand that the offset that the API returned was in seconds, and we have to have the milliseconds for our operation. That's the conversion we did everywhere. And so in this case, we see the correct time. That's the conversion of between time zones, and it's quite a tricky little operation, but it seems like it's working. So also the task recommended that you use the local date stream formatting, just because this, for instance, the day of the weeks, you shouldn't have had translations for that because the browser can translate it for you. And let's take a look at that. So let's just now take our Gdansk time as an example. We can convert it to local string. Then we can pass our local, which it can be anything. Let's just have an English for right now. And we have a date object. Now sometimes there is also a locale associated with the date because different countries have different formatting. For instance, the US it's all English language, as we can see in the left part, but the US has the following locale. Let's take a look at Canada. Canada has a different one. And England, how would you do England? I guess that, or UK, I'm not sure. They all have a different locale, but we can just try this one. Then the second option we can configure is just an object that has quite a lot of properties. For instance, it has weekday. That's the thing that we'd like to see, and we can make it, I believe it's called lawn, and you can see how the language changed, and we know that today's Tuesday, but it's, for instance, it's not in Polish. Let's try to make it Polish, and I hope that this is I don't really know. You should let me know if it's the Polish word, but let's just check in Russian, because the translations work quite nicely with this the local string method. It's internalization API has been added to the web API quite a long ago, and it has not only internalization and localization for dates, but also for numbers and for strings. So that is a bit outside of the scope of of our current discussion, but it's just these nice little features that we should use so as to not complicate our lives with translations, right? And I guess the last thing I wanted to tell you about this translation and all of this date manipulations is that usually in the production level, not necessarily production level, but just if you can use a library, people usually use a library, and Moment.js is, let me just Google it. Moment.js is the library that is used for dates and time manipulations. It's very powerful. It can do a lot of these things so that you don't have to deal with them. Dates and times are really complex. It's, we have to not only convert time zones, but think about, leap years and some weird international daylight saving and whatnot, like a lot of things that happen in dates and times, and you really don't want to. So usually a library like Moment.js is used in projects to deal with dates and times. But in our case, I think we were not allowed to use a library like that. Maybe not, the requirements didn't really specify anything about this library. So I guess you could have also just used that library. Okay. So no questions? No questions, that's fine. Let's see what else we can discuss. Now, let's maybe talk a bit about a responsive web design, because the task specified that your application, it didn't give you a layout that you are supposed to use. Like you see, I have just also not necessarily copied, but okay, now I'm just everywhere. But there's this quite nice application that the task had a link to, and I was just like, let me just let me just do the same type of layout here, layout and look. But you could have used any one, but the requirement said that you have to make it responsive, and the responsive would imply that on any viewport, width and height, your application has to be looking decent and be readable. So in my case, I have used CSS Grid just because we only need to support Chrome, and Chrome supports CSS grids and quite nicely. The only browser right now that doesn't support grid is Internet Explorer, any Internet Explorer, even though IE 11 is in can I use states that it supports it partially. I've just noted that it really doesn't in my case. So yeah, I've based my layout on CSS Grid, and the way I did it is I just had I have divided my application in 4 components. So I have 2 rows and 2 columns for the main layout. So this so the buttons to the left are in one rectangle, let's say, the search box in the second one, and then below we have another 2 boxes that CSS Grid creates. And the weather widget, let's say, it is also done with the CSS Grid. You could have also used, as the task said, something like Bootstrap, which helps with the responsive layouts. But in my opinion, it's kind of it's going to probably maybe not. Okay, let me just say it this way: I haven't used Bootstrap ever, so I obviously don't really maybe not know what I'm talking about here. But it looks like CSS Grid and Flex layouts are going to maybe as well replace. Potentially replace some library like Bootstrap, because it mainly helps with creating your responsive design by having this 12 columns layout. Let's see at my grip, at my grip, at my grid. So here is what we have. We have on my top level element, I have a display grid, and I'm just defining my grid to be to have 3 columns by having this CSS property grid template columns. And you can think of this as just a table with 3 columns. And I have used 3 columns because we have specifically 3 dates that we need to have a forecast for. And I think it kind of looked okay to be done that way. And then for some rows, okay, so right now you can actually see the grid as the browser helps to kind of build a ruler around it. So yeah, we can see grid items. So the big temperature, the main temperature is big, and it takes several parts of the grid, while some properties take fewer parts of the grid, and our forecast takes like this little items at the bottom. Nice part about it is that the grid can be responsive. So for instance, at some point, our grid has changed, and now we have, well, you can see how items have rearranged themselves. And this is what we are talking about in when we talk about responsive design, is that we don't have a big scroll bar. Well, in this case, I have my image. So yeah, that's because of this image. But other than that, responsive web design implies that we don't really have a scroll bar when we don't need it in mobile screens. Now this is a part about the responsiveness. Also, you can see that like the items moved in the wrong way. So yeah, I'll need to fix that. So we have a question. How about months? I guess this is again talking about dates. Yes, let's take a look at my console. Hopefully it's not lost. We can specify months translations as well by having month. So usually month is a numeric number. Numeric, I believe. Let's see that. Okay, incorrect locale information. Well, that's logical. Let's do first, let's do English. So the numeric has this number, which in our case, you probably meant that you would like to have the month be of text value. So we can also try to show the month in long. And so in this way, we can see June. So once we convert it to Polish, we would also see the month, hopefully in the correct, well, it should be because it has also worked in English language. So yeah, months can also be converted. What did you do to see those little dotted lines showing elements? This is actually a feature of Chrome web browser. You don't have to do anything. If Chrome encounters, as far as I know, if Chrome encounters an element that is layout as grid, which we specify here, display grid, it builds this grid for you. That's just a feature of Chromium, and it's amazing. That's just one of also the reasons to use grid if you can, because most of the time in production is, at least in my experience, I still have to support Internet Explorer, and grid is just not possible. But this task is nice because it says you only have to support Chrome, the latest version of Chrome, which is just a dream. Okay, no more questions. It didn't happen for me. I guess let's maybe take a look at the settings, but I'm pretty sure that this just happens out of the box. But I might be wrong. I might have set up something to show the grid. Show rulers, maybe. Let's try to remove show rulers and see what happens. Yeah. Okay. Yeah, still the grid gets shown. So you can probably just try to do the same thing, create a just simple grid layout and in Chrome, and hopefully it works for you, because maybe you just didn't notice last time. Yeah, Flex doesn't show any grids as far as I know. It's only specifically the grid, the display grid, that shows the grid in Chrome. Okay, we have just a little bit of time and I don't see any other questions. So let's maybe talk about the speech synthesis API. It's not something that the task somehow said that you, like a hacker version task said that you should use the speech synthesis API, and there is pretty much two of them. If you looked, there is one that generates speech from text, and the other one that does the opposite. It creates text from speech. I have implemented just a simple example, but I've commented it out for the microphone. Let's take a look at it real quick. So we can find it in the search view. I've closed it because maybe there is something wrong with it, because once I've added it, and it's still an experimental feature as far as I know, because it has a prefix of WebKit, speech recognition, my browser console just started going very slow. Okay, we now have failed to compile. Yeah, probably we'll need to do a little bit of debugging now, which is always fun. Let's try this. Okay, great. So now let's just try to see this language speech recognition. So what we did when we press this little, okay, Moscow, and then it just redirects us to Moscow. Or also this API, which has this WebKit speech recognition API, it knows about languages. So for instance, right now, if I change, oh no, let's say in English, and let's try some city that it probably can't recognize. Moscow. You can see that it didn't find the city, but if we change the language to Russian and do the same, Moskva, it finds the city very well. So it supports the languages, and it's quite amazing, and I really like it. But as far as I know, it's still very experimental, the speech recognition features, and maybe only Chrome has it. You really should just maybe read the MDN for that, because I just kind of skimmed through this so as to create just a simple demo here. But if we take a look at this, what this demo does is here we have a method for the setup of the language. We query selector, which is going to be the mic icon, after which so here we also feature detect, and if the browser does not support the feature, we just hide this mic element so that it doesn't confuse anybody. And the main code is just simply sitting here. We have a speech recognition API that we instantiate, and then we have an object on which we can start. When we call method start on it, it starts listening for the microphone. And at some point, when a person stops speaking, if it understood anything that the person said, it issues a result. And the result comes in as it can potentially have several elements in an array with what was the, let's see, it has this specific word that I don't, let's take a look at the speech recognition result. It has confidence levels, so it can have several words, and it would assign each of them confidence, and I suppose it's from like 0 to 1. In this case, the speech recognition service was really quite sure that the word is what I said, but sometimes it comes with lower coefficients. Maybe let's also take a quick look at the opposite of converting speech to text, which is going to be text to speech. Okay, how about let's see let's try to make to have this current weather contents of this context of this div to be text. So what we'll do is we say let text is going to be query this element, and let's just get its text content, because we don't want our text to read anything that is not any div tags. That's probably not what we'd want to do. And then we'll create a speech utterance. Let's call it that. No, new speech. Speech synthesis utterance, it's called. And then we do speech synthesis.speak. Our speech utterance, but now in this case we didn't put anything in the contents of the utterance, so we're not gonna hear anything, right? So let's try to put text into this. Okay, and now let's speak, and hopefully you can also hear it, but it's probably going to be a very auto-generated text, so to say. Speech synthesis.stop. Oh, well, it's almost over. Yeah, there is a way of stopping the pausing the speech or stopping it, but yeah, we didn't do it here. Let's see about any other questions, guys. If you have any more, let's maybe ask them now because we're almost done. And I think I've covered everything that I particularly wanted to specifically cover. So if nobody has any questions, I would just like to wish you a good evening. Okay, let's see. Yeah, guys, I'll surely share my code. Um, just I would like to say to explain to you again that it's a work in progress, so you just should consider it as just a simple example and not something that is just a perfect solution by no means, because I after having used React for quite a long time, I really don't like to deal with the DOM, and I don't really know if I've done the most, if this is the most clean way of doing it. Like now, after I've started implemented it, I've thought about refactoring all of the views in a different manner, but I just didn't have time before the demo, so I just sticked with this. How about testing fetch with jest? Oh, testing fetch with jest is something that is uh, quite a it's a more complex topic in testing. So let's just because we're supposed to test the app. Yes, let's see. So here I have added a simple unit test as an example to my app. The app is not very well tested, and the specification to the test did not really tell a lot of information about what you should test. So I think what they implied was to unit test your methods, and I don't really think it was about testing fetch. You might want to test the your model, but testing, say, fetch is not really something that I think is commonly done, because fetch is the API that is the browsers, and it's pretty much tested for you. So to say, let's take a look at my test. So what I have added my unit tests in with jest. So for that, I have created a, oh, I don't really see it here, right? Okay, so I guess I haven't yet. Let's create our test maybe quickly right now. So to add jest to the project, if we were to use jest, and jest is a very common unit testing framework / library to use, we will do npm I, we will do then save dev to save jest as a dev dependency, and we'd include jest and also maybe types jest. Types jest is specifically often required for TypeScript, but well, I guess it's still okay for us to add it this way. So now let's add a test folder. In which we'll be adding our test files. And in my opinion, we should test, first of all, we should test our utils methods before services, before the UI testing. They should be tested. So for instance, we can test, let's say I have this simple random number that just is supposed to give me a random number from min to max. Okay, so let's have the describe. And we'd say weather app unit tests. while our dependencies load. So describe is going to be just the name of our test suite, and then we can have test or it for each specific test function. And it should specify what the test is testing. So in my case, for let's just check that jest is working. So it should always be true, work all the time. And we would just do expect true to be true thing. You probably already did a lot of Lodash tasks, so this should all look familiar. Well, I have some syntax errors in my code. Oh, see, this is totally wrong. So yes, the function is expect just text and then a callback. And now finally our justice and the libraries are loaded, and we can either do npx to run jest, or we can add it to our script tag. So see, our jest has found test, and it doesn't like it. Let's see what we have, what problem we have. So it's probably just, yes, this looks better, even though we have some syntax highlighting is coming from ESLint, because it doesn't see these keywords in scope of itself. But we can see here that our test has passed. Well, it should, because it's just checking the true to be true thing. Let's write a real test now, just a very simple one. We are almost out of time here. For that, let's import our random method. Okay, we're in test directory. We go out to source directory. It doesn't really matter where we place our test files. Sometimes they're placed in a test directory, or sometimes they are placed in close to the methods themselves. It is done both ways. And let's check that our random method, if we pass the same value, should always return that value. That's just a simple example of how I would see a random value can be checked. At least that we can check the bounds. Okay, and see, here we have its success. Now it's also common to add the tests to our package.json file, so that we can call it using npm syntax and not npx syntax. And that way, with the watch flag, we can actually watch for changes in our files, and just is going to rerun our tests that it sees necessary whenever it sees a file change. Okay. And we can see here now that now it's going to be watching. Yeah, I'm going to open our app that we've created again now in the browser, and we have about 5 minutes left, so I guess we can just finish our today's mentor sessions. Again, guys, if you have any other topics you would like to discuss, let's do that. Or okay, I hope that you got something out of this lecture. It's quite challenging to present something like this, because it's just a very big task that has a lot of things in it. And yeah, I just would like you to know that if you find it challenging, it is definitely quite a challenging task. I hope it did not discourage anyone from continuing their front-end development um, learning and career. But it also is a very interesting task if you think about it, because it's so very close to our real life. Everybody uses something like a weather app on their phone, and here you can see how, like, have a glimpse of how developers of that app might have implemented it. And even though it looks like such a simple app, like it almost doesn't do anything, how much effort it really takes to create an app like this. Hopefully you noted that. And yeah, I will I will send I will send a link to my repo to the organizer, so you can have access to it, and hopefully they will translate it to you. And I hope that you will take a look at it and maybe have something to compare your own app to. Yeah, because it's always nice to see how an application is done from how another person does an application. Everybody does things differently, so there are a million ways to implement an application like this, and probably none of them are right or wrong. So yes. Okay, guys, I guess let's call this a day. I was really glad to talk to you today, and I wish you success in your uh, front end development journey. And yeah, have a nice evening and bye.